All right, students, we're going to be looking at another of these free response questions that has to do with rates and interpreting those rates with some extrema as well. So the first thing we see is that we have a temperature in Kailua. So one of our main things to note is that we have temperature. So like our units would be in degrees. And we'll say it's degrees Fahrenheit because it's in Hawaii. And T is measured in hours. And we have this equation here and a time interval as well. So let's use all that information to kind of get ourselves set up. So the first part, where we have an equation in there, we're going to type that equation into Desmos as our calculator, because this is a calculator-friendly question. Now I'm typing h of x instead of h prime of x because it will make it easier when you're trying to plot derivatives as well. When you use t, it doesn't plot the derivatives as nicely or conveniently. So we have h of x equals 6 sine e to the x over 12. And then we have minus 12, close the parentheses, and then a plus 72. And you might be thinking, like, where did the graph go? It's like gone. Well, I could zoom out. So let's zoom out to like negative 100 to 100 for my x. And same thing for my y. See if we can find this thing. And sure enough, it is there. It's just very high up in the scale. So we also have this piece of information that gives us our interval, 0 less than or equal to x, less than or equal to 24. Oh, let's not put that in parentheses. We'll just keep it open. And that kind of gives us our zone to zoom in on. Now, when I look at this, I want to kind of narrow our area to that blue. And if I were just on a touch screen, I could kind of spread it out like this. I'm using my fingers on the screen to spread horizontally on the axis. But you can also just kind of adjust that in this settings with the wrench near the top. So I'm going to adjust my x-axis, let's say from like negative 5 to 30 to get just beyond those 0 to 24 in the x direction. And I noticed that our temperature gets up to, just below 100 there. So let's go from negative 5 just so we can see the x-axis, maybe catch any zeros going on in it, maybe negative 10. And we'll go up to 90. And I think that will give us enough information. At this point, I'm going to tap on the gear icon, and there we go. So that red line in the blue zone is what we're looking for. Now, because we just have this as h of x, it will allow us to do h apostrophe of whatever. We could say h prime of x, or we could say h prime of a certain number. And in this case, we're going to do 12. All right, so we have some information here. We have that for part A, let's put us back into pen mode, A, h prime of 12 is going to be equal to negative 1.34525, or 526 if we want to round it off. But I prefer just to truncate. But that's good enough there. So we have that number. And, excuse me, in that number, we need to kind of unpack some of the meaning. So this means that the temperature is decreasing. We should get specific with the word there, that it's decreasing because it's a negative rate at negative 1.34525 degrees per hour at time equals 12 hours. So we're just kind of unpacking all the parts of the unit there. The units and the context and what's actually happening. That's good for part A though. Part B, find all times t for which the temperature of Kailua is increasing. Okay, so increasing would mean positive slope. And it does appear that it dips kind of as we get into the evening, but then it's kind of weirdly like going back up again. So let's see how we could plot that. Well, first, we could just plot h prime of x. And that gives me a handful of zeros. What I'm looking for is when that piece is above the x-axis. So it looks like we dip. We are, let's see, for when it's increasing, we are negative from 0 all the way to this number right here, 17.06578. And then it appears that we're just about right before 24. I'm going to zoom in on that number there. Yeah, it's increasing up until 23.8341. So let's try to get those two numbers together. So we have 17. Oh, let's write our full sentence. We can say the temperature is increasing for, now we have our range, 17.06578 is less than t is less than, then our next dot is this one, 23.83411, because the derivative, so h prime of t, is positive or greater than 0. All right, what is the maximum temperature in Kailua for 0 is less than t is less than 24? Okay, so what we're looking at when we try to find maximum, and let's kind of stay down here near the derivative, is we got to do a couple things. One, we got to check endpoints, because endpoints are where a absolute min or max could occur. But we also need to check critical points. Now, if we're looking for a maximum, a max is going to be when the slope changes from positive to negative, and then we hit a max. So we're going to check endpoints and any relative maxes. Well, the only place where we change from a positive to a negative is when the derivative, h prime of x, changes from, there we go, changes from a, I can't even think right now, changes from a positive height to a negative height. So when the derivative changes from a positive height to a negative height, because the height of h prime is equal to the slope of h. All right, so let's start looking at what things we might have. So we have that number that was 23.83411, and then we have the endpoints. So what we want to do is create a table checking the endpoints and the relative max. So in my table here, I can actually click on my plus sign, add a table, and instead of x1, I'm going to call this t, because those are my t moments. And instead of y1, I'm going to call this capital H of t. Oh, we need parentheses there. So we need parentheses of t. And the reason that's like super helpful is I can just type in my t values and it will calculate my h of t for me. So at time equals 0, we're at 77.9999941. So pretty close to 78 degrees. And then at time equals, now let's plug this number in that we had, 23.83411. We do hit 78 degrees. So it's a little bit higher than when it was at 0. And then for our last one, we're going to say at t equals 24. It dips right barely below. Okay, so this is interesting because these numbers are so narrow in their range. Like we're talking about, 100th of a degree. So, but technically, we do hit that maximum number at 23.83411. So we're going to say for time t, for time h of t, we'll copy our table over here. If you're doing this on a laptop device, you could just screenshot that table and throw it in as well as part of your response. But we're going to just write these out, 23.83411 and 24. And then we have, this is 77.99991. And then we have 78 and 77.969153. And so now our statement is going to be the max temperature is 78 degrees and it occurs at t equals 23.83411. Put my decimal point in there. So I got squeezed a little bit on my space, but I was trying to see if I can fit all this onto one screen so you all could see it there too. All right, so this is my part C. Trying to figure out when the max temperature is. All right, so there we have it. We have our parts A, B, and C. A lot of it's just appropriately interpreting the derivative and applying some context to our responses.